Every login, payment, and AI interaction depends on one invisible layer: digital identity. When it's designed well, you get trust, personalization, and growth. When it isn't, you see fraud, exclusion, and regulatory headaches. In this module, we'll unpack what digital identity is, how it works, and why it matters more than ever. You can think of digital identity as your stand-in when you're not physically present. It's the data that says who or what you are, whether that's a person, a company, a device, or even a software agent. Systems use this data to tell entities apart, decide who to trust and what to allow. When identity fails, security, personalization, and even basic access start to break. Now let's break that identity system into three building blocks. Identifiers are the unique labels that point to an entity: an email, phone number, or national ID. Attributes are the descriptive data around that label: age, address, preferences, risk scores. Credentials are proofs that certain attributes are true, like a passport, employee badge, or verified certificate. The real value comes from how these work together, so systems can recognize someone, understand them, and safely act on that understanding. Identifiers are the basic labels systems use to know that this is you and not someone else, like an email address, phone number, or national ID. Some identifiers are persistent and stick with you for years. Others are ephemeral and exist only for a session. How long they live and where they're reused has huge implications for privacy, tracking, and security. Attributes are the rich details that turn an account into a real person in a system. They describe who you are, what you do, and sometimes what you're likely to do next. Static attributes barely change: your legal name, date of birth, maybe a national ID number. Dynamic attributes constantly move: your current location, account status, spending patterns, even risk scores. Modern products depend on these for personalization and fraud detection. But when attributes are scattered across silos, decisions become slower, less accurate, and sometimes unfair. Credentials are the evidence behind your claims. Not just "I am Alice, but I'm over 18, I own this account, or I passed this background check." They work through a trust triangle. An issuer, like a bank or government, vouches for you. You, as the holder, store that credential and present it when needed. A verifier trusts the issuer, not you directly, and checks the cryptographic proof. Stronger credentials cut fraud, but if they're too clumsy, people abandon the product or route around security. When we talk about a digital profile, we mean the assembled version of everything we've covered: identifiers, attributes, and credentials, bundled into one living record per person. Architecturally, you usually face a spectrum. On one end is a centralized profile, one giant customer database that's easy to query, but also a high-value honeypot for attackers. On the other end are more distributed profiles, stitched together through APIs and federated logins. That choice will shape user experience, how quickly you can update data, and the long-term risk surface you have to manage. Now let's connect identity to access. Think of authentication as the ID check at the building entrance, and authorization as the door rules inside. Authentication proves you are you, using things you know, have, or are. Once that succeeds, authorization decides what you're allowed to do: which data you can see, which buttons you can click, which APIs you can call. Many breaches happen because teams mix these up. Always ask, are we confirming identity or controlling actions? Too often, identity is treated as the login box that IT has to manage. That mindset leaves a lot of value on the table. When identity is designed strategically, it becomes a revenue and trust engine. Accurate, consistent identity data lets you personalize, create tailored journeys, and safely remove friction from high-value actions. At the same time, strong identity underpins fraud prevention, anomaly detection, and regulatory compliance. Cut corners here and you pay twice: in lost conversions and in silent, large-scale fraud and fines. You can see this play out across sectors. In banking, risk-based authentication lets you say yes to good customers faster while still meeting regulations. In e-commerce, a unified identity reduces checkout friction and cuts false declines that cost revenue. Government digital IDs unlock secure self-service at scale. And in enterprises, SSO and clear roles shrink help desk load while tightening security. Identity is never just a login feature. It directly shapes business outcomes. When you design identity for the public sphere, you're really choosing where to sit on a spectrum. On one end, centralized designs give governments and large platforms strong control. That can mean efficiency, consistency, and easier enforcement, but also higher surveillance risk and single points of failure. On the other end, decentralized designs increase user autonomy and privacy, but make regulation, interoperability, and enforcement harder. Your role is to decide which risks you're willing to own, and then govern them explicitly. For years, most identity threats were about stealing or guessing secrets. Passwords, one-time codes, maybe a reused token. Those attacks were dangerous, but they still depended on human effort and scale. Generative AI changes the game. It can manufacture convincing faces, voices, documents, even entire histories for synthetic identities at almost zero marginal cost. It can also drive swarms of autonomous agents that behave like real users. Impersonation is no longer rare, it's industrialized. In a synthetic era, we can't rely on our eyes anymore. Trust has to move from, "Does this look real?" to, "Can I verify this cryptographically?" Picture a trust filter sitting between every user or AI agent and the digital world. On one side, content arrives with provenance, signatures, watermarks, and audit trails. On the other, people and machines present decentralized identifiers and verifiable credentials. Systems then enforce access based on these proofs, creating an ecosystem where authenticity is checked by math, not intuition. To wrap up, identity is an orchestration of identifiers, attributes, and credentials, enforced through authentication and authorization. When you treat identity as a core business engine, you unlock personalization and fraud reduction. When you don't, you create systemic risk. Governance, regulation, and inclusion shape every design choice. And in the AI era, cryptographic provenance becomes the anchor of trust that keeps digital interactions reliable at scale.